Happy House, presented by Creative Kid Stuff. We're taking a look back at some of our favorite experiments with Liz Heineke.
We're gonna let go of your hands and you're gonna put all your weight on the eggs. 1, 2, 3. Are they breaking?
Wow! We're back with science expert Liz Heineke making sidewalk frescoes with a science twist. Stay tuned. Hi, I'm Happi. I learned early on things are much easier with a little help. I also have a few tricks of my own to share. It's go time, people. Welcome to the Happy House, presented by Creative Kid Stuff.
So, remember when I let your kids throw eggs?
Yes.
Yeah, that's a cool real world science experiment. You see how airbags work, because you throw eggs at a sheet and you see if they stop slowly, they don't break. But then we threw them at a fence, remember?
Yes.
And what happened?
They broke.
Explosion.
Yes.
When they stop fast, they break.
I think that they learned something, but I think really they just wanted to throw eggs.
And science should really be all about the fun for kids, right?
Mm-hmm.
I want to confirm a rumor I heard.
What's that?
I heard that there might be a second book coming out. Is that true?
Yes, my kids and I and a bunch of neighborhood kids have been outside doing experiments, digging in the dirt, catching bugs, catching tadpoles, blowing things up.
So more to come.
More to come.
All right.
Yeah.
But today you've got something planned for us. What do we have? What are we doing today?
Well, we're doing an experiment with, what are these guys?
Eggs.
And what kind of animal did these eggs come from?
Chicken.
Yeah. So these eggs are shaped like an arch, right? See all the arches on these eggs?
It's an ovoid.
It's an ovoid. You are smart. Okay, hold the egg in one hand and squeeze it as hard as you can. See if you can break it. You can't break it, can you? Eggs have to be super strong. Why do you think they have to be strong?
Yes.
Because I don't really know that much.
Why do you think eggs have to be
So
strong?
they don't break from like predators and stuff like that?
Yes, and from their moms sitting on them, right? When they're hatching them out.
They have the down, so.
Yes, but they also have to be weak. Why do eggs have to be weak? The shells are thin.
So they can get out.
That's right, so the chicks can peck their way out. Well, today we're going to do some physics experiments with eggs, and I'm super excited. We're going to see what happens when eggs stop slowly versus when they stop really fast.
All right, well, let's get started.
Yeah, and do you think that's a good experiment to do in the house?
Well, maybe not this house.
Maybe not.
It doesn't matter.
Are we going to take it outside?
Yeah, let's take it outside.
All right, let's go. Okay, Liz, we're outside, and we have 2 kids armed with 2 eggs each. What's going to happen here?
I know. Well, the law of motion says an object in motion wants to remain in motion. And if you stop it fast, it stops with a lot of force. So we are going to see what happens when you throw an egg and it stops fast against something like a fence. So you guys go ahead, throw your eggs.
Dead egg!
What happened? Did they stop with a lot of force?
Yes.
Yeah, they did, and that
blew up.
broke. So even their strong shells aren't strong enough for that. Now let's go see what happens when we stop them more slowly. See if you can break them.
All right, let's
All right.
do it.
Always make your kids clean up after they do a science experiment. There's some high up eggshells too. Yeah, the white. Yeah, get that off. There you go.
Okay, we're ready for the next part of our experiment, Liz. What is going to happen now?
Okay, the kids are going to throw their eggs as hard as they can, and we're going to see what happens when eggs hit something that stops them more slowly. So try to break them. Throw them in the middle of the sheet as hard as you can. Did it break?
No!
Harder. One more. Oh, nice. Okay, come see if they broke. Do you guys know what happens when an airbag goes off in a car?
Yeah. It's a bunch of pressure and it's going to send you flying backwards and it's going to hurt.
Right, but it also, if the car is going fast, right, it stops you slowly, just like this sheet stopped your egg. So the eggs didn't break. Yeah, it's just like airbags. You guys want to try one more time?
Yes!
Okay, go for it. Whoa, nice throw. Oh. Nice.
Hey,
Did they
nice
break?
job, you guys. We've just seen what happens when eggs are thrown fast at a hard surface and then basically combust. But now we're going to take a look at how strong eggs can actually be.
Right, we talked about their arch structure. And you see arches in architecture a lot, right guys? Like bridges, you see arches? Well, we're going to see how strong these arches are by actually standing on eggs. And when you do this, you want to make sure all the eggs are pointing the same direction and none of them are broken. But we are going to hold your hands and help you step on. The idea is to evenly distribute your pressure. So you want to step on, go ahead with a really flat foot. Okay, now, Okay, step back now. We're gonna let go of your hands and you're gonna put all your weight on the eggs. 1, 2, 3. Are they breaking? Ella, your turn. Let's try it again. Okay, stay here.
Got this.
Isn't that amazing how strong they are? Oh, she doesn't even want help. Okay.
Okay, ready?
Oh, she's walking on him. Okay, step back. All right. Wow. So they're weak enough. The shells are thin enough that a chick can peck their way out, but they're strong enough that you can stand on them. Is that awesome or what?
That is pretty.
Pretty awesome. Go science, right?
It hurts
Yes.
though.
All right. How do they get off?
Well, I think you should just step off carefully. What do you think would happen if you stepped on them with the high heels on?
Then they would break
Yeah.
like that one did.
Oh, that's pretty good. Out of 24 eggs, how many did we
One egg
break?
broken. That was really neat, Liz. It's pretty impressive. I don't know if I could stand on those eggs. Do you think?
You could. You want to
Okay.
try? Come on.
No. Maybe next time.
Okay, okay.
When we come back, it's all about science and fun. Sometimes we need to take our experiments outside because they are big.
Yeah, like the soda geyser and the Mentos mints. So it's explosive, but when you go outside, it's also super easy to clean stuff up.
And who doesn't like to watch stuff blow up?
Every kid in the world.
Yeah.
Yeah. All right, who wants to sing the science song? Let's do it. Let's do a more rock and roll version this time, okay?
A rock and roll version.
Physics. Biology. Chemistry. Yeah. Physics. Biology. Chemistry. Yeah. Woo, nice. All right. So,
All right, we are here today with Liz Heineke, one of our very favorite scientists, and actually probably one of the coolest, if not the coolest scientists I know. She plays the banjo, the guitar. I mean, what don't you do?
clean my house.
Oh, perfect. Who needs to do that? So Liz has written this Kitchen Science Lab for Kids book, and we are going to do some experiments from there today. And why don't you talk to the kids a little bit about what's going to happen?
Yeah, so I see you guys eyeing this bottle of Diet Coke, and I know that you know what you want to put in there. What do you want to put in there?
Mentos.
Why do you want to put Mentos mints in there? What happens when you put Mentos? So it blows up. What makes it explode? What's the science behind the coolness of the experiment?
Well, the Mentos like disintegrate and has like this chemical in it that makes it explode.
That's right.
But it doesn't taste very good.
So what builds up pressure in the bottle? What kind of gas builds up in the bottle to shoot the liquid out? Can you remember?
Carbon dioxide.
You are so smart. Yes, which is in the atmosphere too, right? All right, and we're going to do another experiment. We are going to use the bike pump there to build up. What happens if you put a cork in a bottle and you put a needle through it and you pump air into it? What happens inside the bottle?
It goes down or like
I never done
doesn't know
that.
what to do.
Well, we're going to see what happens. The air pressure is going to build up. We're going to put some water in the bottle too and see what happens. It's going to be pretty awesome. So,
Are we going to do that right here?
yeah, I don't think so. I don't think those crystal chandeliers can handle the explosions that we are going to.
I don't think so.
Make, yeah.
Let's take it outside.
All right, let's do it.
All right.
I know what's I'm a wet. There.
A little bit more. Is that good?
I'm a little wet too, man. Yeah.
Well, you sprayed me.
We're outside and we are ready to see kind of some explosive experiments. Is this what's going to happen here? We've got bike pumps and some kids who are ready for action. So talk to me about what we're going to do.
Yeah, so this is a great propulsion experiment. And we are going to make, can I see this? We are going to make water bottle rockets. And these actually work the same way as real rockets. When real rockets go off, rocket fuel ignites and a lot of gases are produced that go down, shooting the rocket up into space. Okay. So we're going to do the same thing, but instead of rocket fuel, what's in this bottle, you guys?
Water.
We have a plastic water bottle filled about a third of the way with water. The water is what propels the rocket up into the air. So what we're going to do, we have taken corks and cut them in half and put them on ball inflation needles on a bike pump. You see that, guys? Pretty easy, huh? Then we're going to put these corks tightly into our bottles, which are filled with water. Now, what do you think happens when we pump air into this bottle?
It will explode.
Air pressure builds up, right? And eventually that's going to shoot the cork out of the bottle and the water down. And when the water goes down, for every action, there's an equal and opposite reaction. Where's the rocket going to go?
Up.
Do You guys want to try it?
Yeah.
All right. Our launch pads are just cardboard boxes.
Just shoe boxes.
So we're going to get all set up. I'm going to get these in here tightly. You guys go stand behind your pumps, but don't start to pump until I tell you to. Now, it's really important that the bottle is pointed away from you and that you wear eye protection when you do this experiment. But you want a nice tight fit with the cork because that will help a good seal form and the pressure builds up better. We are going to set these up. Don't start pumping till I tell you.
I want to blow up
We're
the
going to
canteen.
try to shoot them across the street. Let's see how far we can shoot them. I'm going to set them up kind of in the corner of the boxes, and Happy and I are going to stand up and get out of the way. All right, you guys, start pumping. Pump fast. Oh! Keep going. You got it.
Awesome! We blew it up!
Yeah.
Glass
awesome, guys.
did?
Did you guys have fun?
Yes.
Do you want to do it again?
Yeah!
All right. All right, let's do it again.
Oh, put your feet on it.
Put your feet on it,
Go
kid.
really fast, really hard. Put your feet on there.
Okay. Oh my
Come on,
gosh.
keep going.
Woo!
Oh my gosh.
All right, let's see it, Chandler.
Nice. Wow. So that is a cool rocket science experiment you can do in your backyard.
That is so fun.
Inexpensive, easy, but hours of fun.
Lots and lots of fun. Even big kids would love this.
Oh yeah, my older kids like this too.
Now I understand you have another propulsion. I called it an explosive experiment before, but it's propulsion is what we're learning about.
This was a propulsion experiment.
Okay.
The next experiment is going to also be gas pressure, but this is going to be carbon dioxide gas, and we're going to make a fountain.
All right, let's do it.
All right.
We've got one more experiment here, and I know Chandler see this happen before, but I'm not sure he knows exactly why it happens. So can you talk to us about this, Liz?
Yeah, do you guys know what a chemical reaction is?
Yes.
What is
I
it?
know how it works. It's something that mixed together then explodes, fizzes, or changes colors.
Right, you make something new, right? So the new thing we're gonna make, what kind of gas do we make when we do this experiment?
Carbon
Carbon
dioxide.
dioxide. And these mints are special. These are Mentos mints and Diet Coke. And the chemical reaction that happens when you combine them makes lots of carbon dioxide gas all at once because these mints have lots of tiny little holes on them and lots of nucleation sites. Can you guys say nucleation sites?
Nucleation
So lots of bubbles form really fast, and then we are going to see what happens. So we have rolled up tubes of paper, filled them with Mentos mints, right? We're going to hold these over our bottles, and when I tell you to, we're going to drop the mints in to start the chemical reaction.
I actually think I'm going to step out for this one.
Okay, that's a good idea.
I'll watch
All right,
it.
on the count of three, we're going to move our fingers and let all the mints drop in. 1, 2, 3. Was that awesome?
Mine all fell out.
Well, it was the pressure. It shot them out.
Yeah, it literally went.
Was that cool?
Still fizzing.
Is chemistry fun?
Yeah.
Yeah, chemistry is awesome.
And sticky.
And tasty. I have a few minutes left.
Liz, thank you so much. It's always fun and educational, and all of your ideas are so easy and accessible for everybody to do in their own homes.
Well, it was a great adventure. Thanks for having me on.
See you again.
Okay.
Coming up next on the Happy House, presented by Creative Kids Stuff, sidewalk frescoes with a scientific twist. Sometimes things don't go exactly as planned, which is what science is about,
Yep.
but we get a little messier than we even thought we
Yeah. So, are you talking about the sidewalk frescoes?
maybe.
Yeah, so this is a great experiment, but do it on like an old piece of sidewalk. But you mix cornstarch and water together, make cornstarch goo, which is awesome. But if kids put it on a cookie sheet or a sidewalk, they can use toothpicks and food coloring to draw on it. And it's a good example of how real artists made frescoes a long time ago.
It looks beautiful.
It's gorgeous.
It's messy.
Messy.
We're in the backyard and it's all about science. We're having some fun. Liz, we're combining science with art right now?
Yeah, what's better than that? Who likes science?
Me.
Who likes art? Yeah, okay.
I'm scared of science.
No, you shouldn't be.
Okay, all right.
This is science. It's cornstarch and water. How scary is that?
It's not scary.
Not
I have
scary.
those things in my own kitchen.
Totally.
So I love, you gave me a little preview of this project. It's gonna get messy. Who wants to get messy?
Me.
Perfect. But this is from your Outdoor Science Lab for Kids book, which I love.
Thank you.
And Chandler loves.
Yay.
So we are here with some special friends today, and they're going to help us with a project.
Yes, in fact, I'm going to have them get started while I talk about the project.
Okay.
So can you guys measure 1 1/2 cups of water into that pan there? So I gave them each, always let kids do the measuring. It's good for their math skills,
It's
right?
good practice. It's
It's
good.
fun.
It's actually great for fine motor too, because it's hard to pour just a cup.
Yes.
So,
And what's great is it doesn't have to be exact. So we're going to get as close as we can, but go ahead and you can pour it over the pan too in case it spills. So we are going to mix together cornstarch and water to make a non-Newtonian fluid.
non-Newtonian.
Non-Newtonian. All that means is it doesn't really act the way you would expect a fluid or a solid to act.
Is it like a colloid?
That is an excellent question. It is not, that I'm aware of, a colloid. That's okay. Now dump it in.
Yeah, perfect.
But it's called a shear thickening fluid. So the faster you move it, the thicker it gets. Okay, now here's the fun part. See that cornstarch there? Can you guys dump that into the pan?
The kids have done a great job of measuring 1/2 cup plus 1 cup, making 1 1/2 cups of water into this container. What's next, Liz?
Next, they are going to take a full container of cornstarch. I forget how many ounces it is. It's in the book.
Wait,
and
a full like this
let's see.
whole thing?
16 ounces of cornstarch. And they are going to put it down right by the water, put it all the way down there, and then you are going to pour it into the water. Go ahead and mix it in, and then mix it up with your hands. And what you're going to discover is that it's really hard to mix because it has this shear thickening quality. So it gets thicker the more you move it around.
Yep.
So go ahead, guys. Don't be afraid. Get your hands in there and mix it together.
It's getting really messy here.
It does. So keep mixing it. Keep mixing it and mixing it until it's a uniform consistency.
It's so hard.
Is it going to make like a clay or something?
No, it's not actually going to make a clay, but it's going to make something that sort of mimics the plaster that they used in real frescoes.
Okay.
So artists used to make frescoes using clay, lime, and sand. And they would put it on a wall and paint small areas while it's still wet.
Wow.
And when it's exposed to the carbon dioxide in the atmosphere, keep mixing, guys, keep mixing.
I see some powder in there. Okay.
It actually hardens and it can last for thousands of years. So if you do it right, you get this long-lasting art. This won't last for thousands of years. In fact, the great thing about it is when you put the food coloring on and let it dry, it makes sort of like a fresco, but then you can hose it off your sidewalk.
So this.
Okay, so that's okay. Hold it over the container. Now see what happens. Can you put some in your hand? It looks like a liquid, right? But what happens if you move it around? Can you roll it into a ball? Check this out. Can you roll it into a ball? Look at that.
That's crazy.
Isn't that crazy? Can you see that? So it makes a ball, but then when I let it relax, it looks more like a fluid,
So
right?
it's like the melting elf and snowman.
Did you see that, Emerson?
It's like what?
The melting elf and snowman at Critter Kid stuff.
Oh, is it? Maybe it is. Very
a little
cool.
bit like that.
Okay, so this looks great, you guys. It's crazy. Okay, can you help me? The next thing we're gonna do is we are going to pour it. I'm gonna let you guys do this here. Can you come around over by her and help pour it
All right.
onto the sidewalk? Here. I'm gonna come around over here. Okay.
Hey, Ava,
Here,
why
can you
don't
come around to
stand
this
up?
side so you don't step in the food coloring? Okay.
I can't. You're getting it all.
It's all happening right now. Science.
This is why we're
at
doing
its
it
best.
outside. Okay. So we're pouring it onto the sidewalk. We're making our fresco.
Oh my gosh, look at
And we're gonna let it sort of, yeah, why don't you help it along? Isn't this the best stuff to play with ever?
Yeah.
Can you guys see this? Okay. And then we're gonna let it flatten out. Okay, I think that's good. We don't have to worry about getting every single ounce of it.
We're gonna get every single ounce.
Okay.
They're getting it all.
All right. Get it all. Oh my gosh, they are clawing it out of there. Okay, can you guys all reach this? The next thing we're gonna do is we are going, nope, don't use your fingers. We're gonna take toothpicks and watch what happens. Now take your hands off of there. You are gonna paint designs on it. How cool is that?
Awesome.
Okay, so who wants a toothpick?
Me.
Okay.
Oh, you guys, this looks great.
So did you know that Leonardo da Vinci was not very good at making frescoes?
No.
He didn't quite use the right chemistry, and that's why the Last Supper is falling off the wall in Milan.
I did not know
A
that.
little known fact.
That is cool. It creates basically a canvas
Yes.
on your driveway.
Yes.
Yeah. Yes,
And
it
you
actually
can,
does.
and you can actually let it dry. Kids can watch. They can observe it and see what happens as it dries. But I like this project because it's fun to play with as you're making the goo. It's fun to play with the goo, and then you can take this second step of making it into an art project.
It's really cool.
You guys, that looks really good. So what happens is the food coloring, the goo has a consistency, so the food coloring can't move very far. It kind of
Right.
stays. Your designs kind of stay in place.
It's really cool.
Look at mine.
Who can make a sunshine for me?
Me. What is that?
I like the heart.
We've made a mess here,
Huge mess.
which is fine. I like messes.
I do too.
But how do we clean this up?
So I would recommend a garden hose.
Oh,
So
just wash
do-
it away?
Yep, so I would do this in a spot where you're not worried about getting food coloring on, a new driveway or something.
Right.
Find some blacktop or find an old stone to do it on. If you want to be neater, you can even do it in the container where you make the goo.
Oh, yeah.
Or you can bring it indoors on a rainy day.
I was just gonna say this could be an indoor project. Maybe.
absolutely.
It'd be really cool to make. You could leave it in that tub.
Yep.
And settle, and then just draw on
And
it.
just draw on it, yeah. So,
Ava, that's awesome.
but kids have a lot of fun with the garden hose too, so,
Yeah. Yeah.
get out the hose, let them clean
Yeah,
it up.
cleaning's always more fun when you have a lot of water and a hose
yeah.
that you can aim at adults.
And brothers and sisters
yeah.
to,
Yeah. And a hot
spray
day.
it on, and a
Yeah.
hot day.
Liz, this was a lot of fun. Did you guys have fun?
Yeah. I made brown.
You made brown? Oh, also the color mixing.
Oh, color mixing, yeah.
It's fun.
It's another great.
Yes.
Yeah.
Liz, thank you. This was a ton of fun, and I think the kids are still having fun.
Thanks for letting me come out and make a mess.
Yeah.